So let's go ahead and add a little bit from this new paper that just came out in 2025 on the comparison of MJOs, Madden-Julian oscillations, which come from the west into the Western Pacific, or the North Pacific Meridional mode that we discussed in the last podcast. North Pacific Meridional mode has larger impacts on El Nino evolution than the March Madden-Julian oscillation. So the title of the paper is definitive. Remember that March spring months are the critical months because the SST gradient is flat in the tropical Pacific annual cycle, and westerly wind bursts or wind anomalies, weaker trades, whatever, can kick off waves and start the Bjerknes feedback efficiently during this time. Let's read the abstract and look at one figure. I won't go into the details, but basically people do compare these things because we don't have a clear answer. People have also talked about winter surges coming from Asia into the Western Pacific to produce these westerly wind bursts, but nonetheless winds in the Western Pacific around the dateline can be very effective and efficient in kicking off waves and pushing down the thermocline for an El Nino and kick off the feedbacks between the ocean and the atmosphere. The El Nino Southern Oscillation is a key driver of global climate variability. Early season westerly wind bursts have long been suggested to be important for ENSO evolution and diversity, with the Madden-Julian oscillation among the main sources being the main sources of WWBs, westerly wind bursts. The knocking is started in the apartment below, so I'm going to see how bad it gets into the sound on my podcast. However, MJO's contributions to ENSO evolution has been difficult to quantify. Here, using an ensemble hindcast approach specifically designed to isolate internal atmospheric variability, we evaluate the influences of March MJO on subsequent ENSO development. Our results show that March MJO, under a favorable background conditions, so annual cycle or some other anomaly that has the system ready to respond in a coupled way. So MJO by itself has limited impacts on ENSO due to weak equatorial air-sea coupling in spring. So the system is very vulnerable to noise and it's weakly coupled. In comparison, the North Pacific Oscillation induced meridional mode exerts a more sustained influence on ENSO evolution, which is kind of what we implied in the previous podcast. A cyclonic circulation anomaly over Hawaii associated with the North Pacific North American pattern, PNA, also plays a role. So you're saying PN, North Pacific Oscillation NPO, and Pacific North American pattern PNA can also play a role, and via Pacific Meridional mode or directly. These findings suggest that March MJO activity alone may not be a reliable predictor for ENSO evolution, but underscore the importance of North Pacific atmospheric variability. These are internal variabilities because they are not forced externally by greenhouse gases or anything else. And secondly, you can imagine that predictions are harder when things just are generated internally via nonlinearities in the system as opposed to external forcing that is giving you a lead time for predictions and so on. Okay. This is just an experiment. Ocean atmosphere responds to the March NPO North Pacific Oscillation. Ensemble spread of the precipitation in color shading and surface winds shown as arrows obviously regressed onto the second PC principal component of EOF2 that is shown in another figure that I've skipped. But basically the idea is that you look at the March precipitation and surface winds that are starting here. It's induced by the North Pacific Oscillation. There is a debate about the independence of NPO, PNA, the Arctic mode or the circumpolar mode, and so on and so forth. But nonetheless, this one gives you signatures. So by April, precipitation and surface winds strong here but weakened here, but have produced a signature in the tropical Pacific. June precipitation and surface winds still have the signature that started here in the winter months of NPO manifest into spring signatures in precipitation and surface winds. Winter is the surface temperature, trade winds weakening, wind evaporation SST feedbacks, then creating this signature. So September precipitation and surface winds, December precipitation and surface winds. So now you have a full-blown coupled signature, and precipitation basically means moving heat source, right? So if you look at the manifestation in the SSTs and winds, then you begin to see more clearly the Pacific Meridional mode kind of pattern here now, apart from this. So this you are creating a response, and by April, you have created the seasonal footprinting peaking into the deep tropics, and the other subtropical deep convection response, trade wind cloud response, all happening because that's already involved here. June SST and surface winds, more clearly you can see westerly wind anomalies and SST anomalies. So September and December, so by December you have something like El Nino. So you have gone from previous winter into next winter. Is this convincing? There is also a figure of the MJO forced response, and as the abstract says, basically the argument is that MJO forcing is not as effective as the NPO and Pacific Meridional mode forcing into ENSO. Okay, so let's leave it there. Both together have papers that are associated with them, not just the ones I showed, but there are many papers. The previous podcast on Pacific Meridional mode and El Nino is a very nice review paper by Dillon at Maya. You can read, and he has tons of references and other details of these things. Okay, so when we started with the role of westerly wind bursts, we argued already that the stochastic forcing is not a necessary condition, because there's not a sufficient condition, because there are years when westerly wind bursts happen, but coupled feedbacks and El Nino doesn't necessarily happen. So there is always an issue of timing. Westerly wind bursts may happen every year, but when they happen during a certain time of the year, and when the background condition of the discharge, East Pacific warming, thermocline, everything is in place, they may grow. But this paper is arguing that this process of westerly wind bursts or wind anomalies and growing coupled mode into El Nino is more effective via the Pacific Meridional mode triggered by the North Pacific Oscillation. Circular arguments? Not necessarily, but all we need to do is try to understand as many things as possible to see if models can somehow improve their predictions. Because if the models are not doing the North Pacific Oscillation well, then you can see if its impact is appearing on the deficiencies in the El Nino of that model. Then you have to worry about why NPO is not being done well, or whether NPO is not triggering enough Pacific Meridional modes, or if meridional modes are not affecting the tropics as they do in the observations. So a chicken and egg problem in coupled models is very difficult, but understanding the processes always helps to deconvolve all the details. Okay, see you in the next topic.